Hello students, it's Nazia Begum here, your physics lecturer, welcoming you all in today's lecture. So in previous lecture we have studied about the superposition of waves at a point P, and from that we have find out the intensity of the resultant wave. Okay, and the formula of intensity is written in front of you. I equals to I1 plus I2 plus 2 under root I1 I2 cos phi. This formula we have got for intensity. Okay, now suppose if we are getting the bright fringe, so that time the intensity will be maximum, and when we are getting the dark fringe, that time the intensity will be minimum. Okay, so at once there will be constructive interference. In constructive interference the intensity will be maximum. Okay, and at the points of dark fringes there will be destructive interference, and at destructive interference the intensity will be minimum. Okay, so by this formula we can get two values of intensity as maximum intensity and minimum intensity. So now let me tell you first that how from this formula we can get maximum and minimum intensity. Okay, so here in front of you can see I have written the formula of intensity. I equals to I1 plus I2 plus 2 root over I1 into root over I2 cos phi. Okay, if in this equation I put cos phi equals to 1, so that time it can be written as I equals to I1 plus I2 plus 2 I1 I2. Okay, cos phi becomes 1 here. Now I can also write I1 as under root I1 whole square. Okay, under root I1 I square means I1 only. So I1 can be written as under root I1 square, I2 can be written as under root I2 square. So if you look at this, you will see it is formula of a square plus b square plus 2ab. Okay, so this whole equation can be written as I1 plus I2 whole square. This will be the maximum intensity. Now if we put cos phi equals to minus 1, so that time what happened? That time in place of this plus 2 I1 I2, we will have minus 2 under root I1 under root I2. If we put cos phi here, this cos phi is there. If we put cos phi equals to minus 1, so this equation will take this form. I equals to I1 plus I2 minus 2 I1 into I2. Now again I can write I1 as under root I1 square and I2 as under root I2 square minus 2 I1 I2. So here this is the formula of a minus b square. So I equals to under root I1 minus under root I2 whole square, and here the intensity will be minimum. Okay, so please students keep this in your mind that if we want the intensity to be maximum, cos phi should be equals to 1. If we want the intensity to be minimum, for maximum intensity cos phi should be equals to 1, and for minimum intensity cos phi should be equals to minus 1. This thing you please keep in your mind. Okay, so now let's see what is the condition for constructive interference. So right now I have explained you that how by putting the value of cos phi we can get maximum and minimum value of I. So if we want the resultant intensity to be maximum, so that time cos phi should be equals to 1. Okay, and the value of cos phi is 1 for phi equals to 0, 2 pi, 4 pi, etc. Okay, when theta equals to 0 degree or 180 degree, 0 degree, 360 degree, 720 degree, so that time we are getting cos theta equals to 1, है ना. So if cos phi is 1, that means the phi should be equals to 0 degree, 2 pi degree, 4 pi degree, etc. Okay, now if we see in the wave, if in a propagating wave we see 0 degree, 2 pi degree, etc., so that represent the wavelength. How? Let me explain you. Okay, now suppose here we have one propagating wave in front of us. Okay, so when I say 0 degree, that means this point. When I say 360 degree, see, it is 0 degree, this is 360 degree, that means 2 pi. Okay, here we have 90 degree, here we have 180 degree, here we have 270 degree, and here at this point we will have 360 degree, that means 2 pi. Here the value will be 0 degree and here the value will be 2 pi. Similarly, here at this point, okay, we will have value 4 pi. So I hope you all have understood that if we talk about the phase difference of 0 degree, 2 pi degree, 4 pi degree, etc., so for that particular phase difference, the wave has traveled one full circle. That means 2 pi degree means a path difference of lambda. Lambda is called wavelength. When a wave travel a complete circle, so that much distance is called what? It is called lambda. Okay, so when we move from 0 to 2 pi degree or from 2 pi to 4 pi degree, so that time a full wavelength has been traveled. Okay, so here you can see it is written, since a phase difference of 2 pi corresponds to a path difference of lambda, as I have explained you now. Okay, so 2 pi difference means the wavelength lambda. So whatever path difference p is there, okay, path difference between two superposing wave, it is given by p. Now let me show you that what is the path difference. Okay, so here we have another demonstration of Young's double slit experiment. Now here you can see we have two sources, S1 and S2. This is the line which is going from S1 to point P, okay, and this is the line which is going from S2 to P. So these two lines are going, that means these are the two waves. One wave is going from S1, one wave is going from S2. These two waves, when going to P, they both have traveled different path. Okay, and the value of S2P, here you can see the value of S2P is more in comparison with S1P. So if we want to find out the path difference, okay, how much path they have traveled, S2 have traveled path from here to here, S1 has traveled a path from here to here. Okay, so they both have traveled different paths. So if we want to find out the path difference between them, it will be equals to S2P minus S1P. Okay, so whatever path they have traveled, the difference between their path is called path difference, which is shown here by P. And when phi equals to 0, 2 pi, 4 pi degree, okay, so that time the path difference is lambda, 2 lambda, 3 lambda, etc. So here you can see 2 pi p equals to lambda equals to 0, 2 pi, 4 pi, etc. Or we can also say p equals to, when we transport lambda and 2 pi on the right hand side, so we get this formula, p equals to 0 pi 0 lambda, 2 lambda, 3 lambda, etc. Or in general we can write p equals to n lambda. So this is the second condition we have got for constructive interference. Okay, what was the first condition? The first condition was that cos phi should be equals to 1 or phi should be equals to 0, 2 pi, 4 pi, etc. Okay, and phi equals to 0, 2 pi, 4 pi, that time we have got p equals to n lambda. So here we have the two conditions. Okay, so now let's read this statement. Hence the resultant intensity at a point is maximum when the phase difference between the two superposing wave is an even multiple of pi. See, 2 pi, 4 pi, etc. is written there. So either it should be the even multiple of pi or the path difference is an integral multiple of wavelength lambda. So this is the condition of constructive interference. Okay, then here we have one figure. Okay, this figure is showing the locus of points for which S1p minus S2p, that is the path difference, is equals to 0, plus minus lambda, plus minus 2 lambda, plus minus 3 lambda, etc. So why plus minus is written here? Because in the diagram you can see we have put n equals to 0, n equals to 1, n equals to 2, n equals to 3, as we have also put n equals to minus 1, n equals to minus 2, n equals to minus 3, etc. And for all these values of n, for a path difference p equals to n lambda, for all these values we are having the bright fringes, constructive fringes. Okay. Now let's find out the condition for destructive interference. Okay, so I have explained you that the resultant intensity at the point P will be minimum when cos phi equals to minus 1 or phi equals to pi, 3 pi, 5 pi, etc. See, cos phi equals to minus 1 and cos is having negative value for the angle of 180 degree, 270 degree, etc. Okay, so cos phi equals to minus 1, that time phi will be equal to pi, 3 pi, 5 pi, etc. So here again you can see the phase difference is 2 pi. Pi to 3 pi the difference is 2 pi. Then 3 pi to 5 pi again the difference is 2 pi. Okay. Or we can write, so because the difference is 2 pi, so here you can see 2 pi p upon lambda should be equals to pi, 3 pi, 5 pi, etc. And we transport lambda and 2 pi on the right hand side. So we have p equals to lambda upon 2, 3 lambda upon 2, 5 lambda upon 2, or in general we can write as 2n plus 1 into lambda upon 2. Okay, where the value of n will start from 0. When we put n equals to 0, we will have lambda upon 2. When we put n equals to 1, we will have 3 lambda upon 2 and so on. Okay, so here we have seen that for destructive interference, the value of phi should be equals to 3 pi, pi, 3 pi, 5 pi. That means odd multiple of pi, or path p should be equals to 2n plus 1 lambda by 2. Okay, so now let's see the statement. Hence, the resultant intensity at a point is minimum when the phase difference between the two superposing wave is an odd multiple of pi, or the path difference is an odd multiple of lambda by 2. See, here it is written 2n plus 1. 2n plus 1 indicates the odd number. Okay, so the path difference should be the odd multiple of lambda by 2. This is the condition for destructive interference. So I hope the constructive and destructive interference is clear to you. It is directly linked to the formula of intensity. If you understand the formula of intensity, then you can find out these conditions. Okay, and one more thing you have to keep in your mind, that a difference in phase of 2 pi. Okay, if there is a phase difference of 2 pi, so it indicates a full wavelength lambda. Okay, now let's move to coherent and incoherent sources. So what is coherent source? Two sources of light which continuously emit light waves of same frequency, okay, same frequency or wavelength, with a zero or constant phase difference between them are called coherent sources. Okay, so two sources which are having light of same frequency or wavelength, and the most important thing is that either they both should have no phase difference, or if the phase difference is there, so that should be constant. So those two sources will be called as coherent sources. And two sources of light which do not emit light waves with a constant phase difference are called incoherent sources. So suppose two sources are there which are emitting light of whatever frequency, same or different, whatever frequency is there, but the phase difference between them is not constant. So those sources will be called as incoherent sources. Now let's discuss the need of coherent sources for the production of interference pattern. See, when two monochromatic waves of intensity I1 and I2 and phase difference phi meet at one point, the resultant intensity is given by I equals to I1 plus I2 plus 2 under root I1 I2 cos phi. The last term 2 under root I1 I2 cos phi is called interference term. Okay. Now for this interference term, there are two possibilities. The first one is that if cos phi remains constant with time, the total intensity at any point will be constant. The intensity will be maximum for cos phi equals to plus 1 and it will be minimum for cos phi equals to minus 1. Okay. So in both the cases, the sources will be coherent. Why? Because whether it is plus 1 or minus 1, but it is fixed. So that time both the sources will be coherent. Second condition, if cos phi varies continuously with time, assuming both positive and negative values, okay, then the average value of cos phi will be 0. Are you understanding it? If cos phi is plus 1, then it's okay. If cos phi is minus 1, then also it's okay. But if cos phi varies between plus 1 and minus 1, so when we add all the values, okay, some values will be in positive, same number of values will be in negative. So when we add them, the total value we will get as 0. Okay. So cos phi will be 0 over time interval of measurement. Then interference term averages to 0. Okay. And intensity I will be I1 plus I2 at every point. At every point I will be equals to I1 plus I2. So that means if at each point intensity is same, that means the whole screen which is in front of the slit, the whole screen will get illuminated and we are not going to get the dark and bright fringes. We are not going to get the pattern. And interference means some kind of pattern only we have to get. That is called interference. And when if we are not getting the pattern, but the whole screen is illuminating, in the whole screen full bright screen is there, full bright fringe is there, so that is not called the interference. Okay. So for interference there should be a fixed phase difference. Okay. A fixed phase difference or no phase difference should be there. But if the value of phase difference varies, so that time interference will not take place. Okay. Is it clear to you all? I hope it's clear. If not, then you can ask me in doubt clearing session. Hence, to observe interference, we need to have two sources with the same frequency and with a stable phase difference. Such a pair of sources are called coherent sources. So question can be asked in examination that why there is need of coherent source for interference. So that two cases you can discuss there. Okay. Now let's move to next topic. Two independent sources cannot be coherent. Okay. If you remember, then in Young's double slit experiment, before S1 and S2, we have one point S. Okay. From that point the lights were coming and then that light waves were divided into two part, S1 and S2. But before that they both were coming from the same source. Okay. And then only we are getting that interference pattern. If the light waves are from starting, if the light waves are coming from the two different sources, so that time we are not going to get the interference pattern. Okay. And why we are not going to get that pattern? The reasons are written here. First, light is emitted by individual atoms and not by the bulk of matter acting as a whole. Okay. So that source cannot be coherent. If the source is not coherent, we are not going to get interference fringes. Okay. So two independent sources cannot be coherent because in both the sources the light is emitted by individual atoms and not by the bulk matter. Second, Even a tiniest source consists of millions of atoms, and emission of light by them takes place independently. Third, even an atom emits an unbroken wave of about 10 to the power minus 8 second due to its transition from a higher energy state to a lower energy state. The millions of atoms of a source cannot emit waves in the same phase. The light emitted by the commonly used monochromatic source remains coherent for about 10 to the power minus 8 second. After this time, the atoms responsible for emission of light get changed. The phase difference and hence the interference pattern changes 10 to the power 8 times in 1 second. Our eyes cannot see such rapid changes and a uniform illumination is seen on the screen. So that's why two independent light sources cannot produce a sustained interference. So the main reason of two independent light sources not being able to produce interference pattern is that in each source the light waves are coming from different atoms, and because different atoms cannot stay in their particular energy state for a time more than 10 to the power minus 8 second, after that time they change their places, and according to that their phase also change. Okay, there will be change in their phase also, and that's why because they change their energy state 10 to the power 8 times in 1 second. Okay, how many times in 1 second? 10 to the power 8 times the atoms are changing their energy state, and our eyes are not so efficient to see that change. That's why we are not able to see the interference pattern when the light is coming from two different sources. So to achieve the interference pattern, there is a very essential condition that the lights should come from the one source, one individual source. Okay. So this is it for today's lecture. In next lecture we will study about the conditions to get the coherent sources and all, and so many other things we are going to discuss about the fringes which we are getting in Young's double slit experiment. Okay students, so see you in next lecture. Till then, goodbye, take care, do some productive work, and the most important thing, be healthy, be safe.